Okay. So if we had to find the zeros, again, it means substitute the f of x is 0. And then, because the only way we really know to do this, at least algebraically, is factor. You know, do you see any greatest common factor we could take out? X squared, right? Every one of these has got an x squared in it, at least, right? So this is 0 equals x squared times x squared plus 6x plus 8. Okay? Now what's left in the parentheses is the quadratic we can factor, right? Which is 4 and 2, right? 4 times 2 is 8. 4 plus 2 is 6. So this is x plus 4, x plus 2. Okay, so what are the zeros? Andrew, did you raise your hand? What are the zeros here? Negative 4. There you go. 0, negative 4, negative 2. Don't forget the x that doesn't have a plus or a minus after, then 0 is the 0, right? If I substitute 0 here, 0 times anything is 0. That definitely solves it. Okay, now, if you look at the graph on the next slide, right, this is what we just found. This is what we just found. And if I look at the graph, you know, it's a 4th degree polynomial, so we would expect that it could have 3 terms in it, right? It started positive, it ended positive. It has zeros, it looks like, at negative 4, negative 2, and 0, which we said already. But it's definitely doing something different at x equals 0 than it is at the other two. I mean, I zoomed in here, and you can see what's going on, right? It's actually, at negative 2, the graph goes right through negative 2. But here, it just touches the x-axis and goes back in the same direction, right? What do you think is the reason for that? Seeing where those zeros came from, seeing where they came from, what was different about the factor? It's squared, right? So what happens when you square something? If you square a negative, you get a positive. If you square a positive, you get a positive. Meaning that when the graph touches the 0, it doesn't change sign. It actually keeps the same sign. That's why it touches that, and then it goes back in the same direction. Right? That's what you expect. That's what you expect anytime you're raising a factor to an even power. If that was 2 or 4 or 6, then that's what you see on the graph. Now, when a factor is raised to a power, you call that multiplicity. Right? This is called the multiplicity. It's a new word. It's probably a movie or something, isn't it? Multiplicity. Okay, catch up. Multiplicity equals 2. Because it's there more than once. And again, the important thing is, when it's an even multiplicity, that means on the graph, you expect to see this.